Good morning, dear students. Today we will learn the matrix determinant and its properties. In previous class, we learned the determinant of a matrix of 2 by 2 and 3 by 3 matrix. So here in this class we will learn the determinants of matrix and determinant properties. Laplace expansion, which we know that is the process of the finding determinant of a matrix. So objectives: on completion of this period, you would be able to know the Laplace's expansion to find the value of a determinant. Understand the properties of determinants. Determinant means every square matrix has a value, its value. So that unique value is called determinant. What are the cofactors of minus 3 and 4 of the determinant? 2, 1, 1, 1 minus 2 minus 3, 3, 2, 4. Here the question is cofactor of minus 3. So to find cofactor of minus 3, first we have to decide the sign. Cofactor of an element is sign into its minor. Sign we can say directly, or we have one formula, that is minus 1 whole power I plus j. I means number of row and j means number of column where the element is located. Here minus 3 is located in the second row, so I is 2 and j is j is 3. So minus 1 whole power 2 plus 3 into minor of the minus 3. To find the minor, we have to remove the row and column where the minus 3 intersected, and after removing that elements, remaining elements minor or determinant. So 2, 1, 3, 2, that equals to minus of 4 minus 3, that equals to minus 1. So cofactor of minus 3 is minus 1. And similarly, we have to find cofactor of 4. Here 4 is located in third row, third column. So directly we say it is a positive sign. So by the rule, or if we substitute in the format, that is minus 1 whole power I plus j, then also we will get positive, that is minus 1 whole power 3 plus 3 into its minor. The minor is determinant of 2 1 1 minus 2, so that equals to minus 4 minus 1. Minus 4 minus 1 is equals to minus 5. Just a second. Next, see the next slide. Expand the determinant of AHG HBF GFC. The expansion of the determinant is equals to, here we are expanding by first row, so A into BC minus F square minus H into HC minus FG plus G into HF minus BG. The next slide. Laplace's expansion. Consider the determinant delta equals to delta of A1 B1 C1 A2 B2 C2 A3 B3 C3. The expansion of the determinant along its first row is delta equals to A1 of B2 C3 minus B3 C2 and minus B1 into A2 C3 minus C2 A3 plus C1 into A2 B3 minus B2 A3. This can also be expressed as delta equals to small a1 into capital A1 plus small b1 into capital B1 plus small c1 into capital C1, where capital A1, B1, C1 are the cofactors of the corresponding elements, and small a1, b1, c1 are the elements of the matrix or determinant. Similarly, if we expanding by second row, we get delta equals to small a2 into capital A2 plus small b2 into capital B2 plus small c2 into capital C2. And if we expanding by third row, then we can write that equals to small a3 into capital A3 plus b3 into capital B3 plus c3 into capital C3. And we can expand by first column also to find the determinant. So then we get at the end all are equal, but here we are mentioning to know we can find with any row or any column. So here the determinant is showing like 3 rows and 3 columns. From these we can select any one. So if we expand by first column, we get A1 capital A1 plus A2 into capital A2 plus A3 into capital A3 that equals to, if you expand by second column, that is b1 capital B1 plus b2 capital B2 plus b3 capital B3. Similarly, if you expand third column, we can express as a C1 into capital C1 plus C2 into capital C2 plus C3 into capital C3, where A, B, C are the cofactors of the corresponding elements small a1, b1, c1, or we can write ai, bi, ci respectively for I equals to 1, 2, 3. And here capital letters we can indicate with ai, bi, ci, where I is equals to 1, 2, 3. So here capital letters are indicated for cofactors and smaller elements. Next slide. Therefore, the sum of the products of the elements of any row or column with the corresponding cofactors is equal to the value of the determinant. These expansions are known as Laplace's expansions, named after the French mathematician Pierre Simon, Marquis de Laplace. So, to find the determinant, we are doing one expansion. That expansion is called Laplace expansion. So, he is a French mathematician, and Pierre Simon Marquis de Laplace. In the next slide, we can see the Laplace. Pierre Simon Marquis de Laplace. He born in March 23, 1749, and he was died March 5, 1827. Nearly he lived 77 years. Great. Next slide. The sum of the products of the elements of any row or column with corresponding cofactors of some other row is 0. In general, ai into capital AJ plus bi into capital BJ plus ci into capital CJ, that equal to delta, where when I equal to j, and that equal to 0 when I is not equals to j. So the sum of the products of the elements of any row or column with the corresponding cofactors of some other row is 0. So if same row, same elements cofactors, sum of the products is, we will get the value for determinant, or we can say it is determinant. But the another cofactors product with another row or columns elements, sum is 0. next example, to find the value of determinant by using Laplace's expansion. Here we are seeing with the number. In previous slide we saw the letters. Here it is given in numerals. See the question: to find the value of the determinant by using Laplace expansion. See here the question, or we can say the example or model question. Consider delta equals to that of 1 minus 3 to 4 minus 1 to 3 5 2. The cofactors of the elements of the first row are: the cofactors of 1 is minus 1 whole power 1 plus 1 into its minor, the determinant of minus 1 2 5 2, that equals to the minus 1 whole power 2 is a positive sign, or we say plus 1, into determinant is minus 2 minus 10, that equals to minus 12. Like this we have to find the second element of the first row, that is cofactor of minus 3 is, it is a negative symbol with its minor, so minus 1 whole power 1 plus 2 into that of 4 2 3 2, that equals to minus of 8 minus 6, that equals to minus 2. And the cofactor of 2 is minus 1 whole power 1 plus 2. Actually it is 1 plus 3, because 2 is last element in the first row and it is located at third column, so it is 3. Unfortunately wrongly entered, or while typing instead of 3 it is came 2, so it is positive symbol, and determinant is 20 minus of minus plus 3. 20 plus 3 equals to 23. By Laplace's expansion of first row we get delta equals to 1 into minus 12 plus minus 3 of minus 2 plus 2 of 23, that equals to minus 12 plus 6 plus 46. So 46 plus 6 52, and 52 minus 12 is 40. So the determinant of the given matrix, or according to the question or data, the value is 40. Sometimes they will put in the square brackets and give as a matrix elements and asks find the determinant, or sometimes they can ask directly they put the elements in two parallel lines, and we have to understand here that is symbolic to the determinant. So similarly the cofactors of the elements of the second row are here. Now we are finding the second row cofactors. Second row contains again 3 elements. For each element we are doing finding cofactors. So cofactor of 4 equals to minus 1 whole power 2 plus 1 into its minor, that is data of minus 3 to 5 2, that equals to minus of minus 6 minus 10, that equals to 16. Cofactor of minus 1 equals to minus 1 whole power 2 plus 2 into data 1 2 3 2, that equals to 2 minus 6, that equals to minus 4. Next, cofactor of 2 equals to minus 1 whole power 2 plus 3 into data determinant of 1 minus 3 3 5, that equals to minus of 5 plus 9 equals to minus 14. By expansion of the second row, we get 4 into 16 minus 1 into minus 4 plus 2 into minus 14 equals to 40. Similarly, the sum of elements of a row 1 multiplied by the cofactors of the corresponding elements of the row 2 is 0, as we can see below. Here the elements and cofactors are not corresponding, then its product and the sum is resultantly we get 0. We can observe here. Next slide. Shortcut method to find the value of a determinant of order 3 due to Saras. So consider delta equals to AHG, HBF, GFC. Write the 3 columns and repeat first 2 columns and draw the arrows diagonally as shown below. AHG, AH, HBF, HB, GFC, GF, and so draw and see next what or how. Add the products on the downward moving arrows and subtract the product of the numbers lying on the upward moving arrows. Add the products on the downward moving, that is AB plus HF plus HG and plus BC, GF, HF. Or we can see ABC plus HFG plus GHF. Okay, we have to see the downwards for 3 elements. First downwards we can see ABC plus HFG plus GHF. So here we are taken the downward moving arrows elements product and we added. Subtract the product of the numbers lying on the upward moving arrows. So upward moving arrows is G square B. So subtract, so that we have to put minus F square into A minus H square into C. So that equals to ABC plus 2FGH minus AF square minus BG square minus CH square. This method does not work for higher order determinants. It is given for generally 3 by 3 ordered matrix. So this arrow symbol is also very easy if we have little time, or if it is a 1 mark question we can go through this also, or we can calculate as the Laplace expansions method, or we can use calculator if we know the how to enter the determinant mode in the calculator, then also we will get the value. So this shortcut is also very simple and very easy to remember. Just downward arrows we have to add and upward arrows we have to subtract after products. So add the products on the downward moving arrows and subtract the product of the numbers lying on the upward moving arrows. Next slide. Properties of determinants. These properties are true for determinants of any order. These are often used to simplify the determinant before expanding. So sometimes properties are used for easy calculations, or simplification is easy if we have simple numbers or little numbers. The number value is very low, so that the calculation part is very easy. So simplify the determinant. And next, here see the property. Here we can say the first one property, reflection property. The determinant remains unaltered of its rows are changed into columns and the columns into rows. Here, if we change the rows into columns in the determinant, the determinant value is unaltered, that means unchanged. It means it is equal to the first when we are not changed, that value is equal to the after changing its rows into a column are same. Here we can see, for example, a1 b1 c1. In this first determinant we have the 3 rows, a2 b2 c2 a3 b3. In the second determinant, or you can say right side of the determinant, here rows are changed into a column, that is a column a1 b1 c1. So though the rows are changed into a column, but outward its value is same. For example, the determinant first left side determinant is if we get 5, and the right side determinant value is also 5. Though we are changing its rows into a column, but the determinant value is not changed, unaltered. This is the property of the determinant, one of the property. So we can say this is a reflection property. Next slide, all zero property. If all the elements of a row or column are 0, then the determinant is 0. So we need not to calculate, because in any row or any column contains 0 means generally to find the determinant we will expand by using any row or column. So if all elements are 0 means their product is 0, then their summation is 0, so the final value is 0. So simply say if any row or any column contains zeros, then its determinant is 0. Next slide we will see switching property. The interchange of any 2 rows or columns of the determinant changes its sign. For example, if delta equals to determinant of a1 b1 c1, a2 b2 c2, a3 b3 c3, and delta dash equals to determinant of a3 b3 c3, a2 b2 c2, a1 b1 c, then here in delta and delta dash, if you observe, the first row and third row are interchanged. The difference is for delta and delta dash, first and third rows are interchanged. So its determinants are different only with the sign. The value is same, but if the first one determinant delta equal to 5, then second one's determinant is minus 5. So 5 is common, just its sign is changed, because when we are interchanged 2 rows or columns, the determinant is same, but its sign will be changed. So that's why delta equals to minus delta dash. Here it is given in the yellow shaded background. Next slide. repetition property. If all the elements of a row or column are identical to the elements of the some other row, then the determinant is 0. If all the elements of a row or column are identical to the elements of the some other row or column, then the determinant is 0. For example, here we can see A1, B1, C1, A2, B2, C2, and A1, B1, C. So determinant of these elements equals to 0. We need not to find. If we find also, we get its determinant is 0. Because here R1 and R3 are equal. So we can say directly, if rows are equal, then its determinant is 0. Not only rows, if columns are also equal, then its determinant is 0. So similarly, we can see in the another example here. First column is A1, A2, A3. Second column also A1, A2, A3. Third column is C1, C2, C3. Then its determinant is 0. As C1 equals to C2. We'll move for next slide. Scalar multiple property. If all the elements of a row or column of a determinant are multiplied by a non-zero constant, then the determinant gets multiplied by the same constant. If all the elements of a row or column of a determinant are multiplied by a non-zero constant, then the determinant gets multiplied by the same constant. For example, here k in the first row, observe the left side. First row elements are k into A1, k into B1, k into C. Second row is A2, B2, C2. Third row is A3, B3, C3 equals to k of A1, B1, C1, A2, B2, C2, A3, B3, C3. So if any row or column multiplied by a non-zero constant, then the determinant gets multiplied by the same constant, like factor we can say. Next, proportionality property. If the elements of a row or column are proportional to the elements of the some other row or column, then the determinant is 0. For example, A1, B1, C1, A2, B2, C2, k into A1, k into B1, k into C. Here first row and third row are in a proportional way. There is only different is only k times different. So if we put the k outside, then both rows are equal. So when two rows are equal, its determinant is 0. So k into 0, 0. Next slide. Sum property. If each element of a row or column determinant is expressed as a sum of two or more terms, then the determinant can be expressed as the sum of two or more determinants. For example, a1 plus b1 c1 d1, a2 plus b2 c2 d2, a3 plus b3 c3 d3 equals to that of a1 c1 d1, a2 c2 d2, a3 c3 d3 plus d1 c1 d1, b2 c2 d2, b3 c3 d3. So this is we can express the addition of two determinants if we have like column there, like here in this example. If each element of a row or column of a determinant is expressed as a sum of two or more terms, then the determinant can be expressed as the sum of two or more determinants. If the first column is expressed in two terms, so in the right side also we are expressed for the given determinant sum of two determinants. Next, property of invariance. If to each element of any row or column of a determinant are added or subtracted with k times the corresponding elements of any row or column, then the determinant remains unchanged. For example, a1 b1 c1, a2 b2 c2, a3 b3 c3 equals to a1 plus kb1 plus klc1. Here we did the first row to we are added the second row with multiplied by in the first column we added to the first column with k times to the second column plus L times, or you can say C1 gives C1 plus K into C2 plus K L into C3. So here we have to understand we can add one column to another column after multiplication to the column. So here we are multiplied K to C2 and L to C3, and after multiplication we are added to the first column. So though we added like this, at the end the determinant is unchanged. If to each element of a row or column determinant are added or subtracted with k times the corresponding elements of any row, and the determinant remains unchanged. Here not only k times, we are taken L times to the C3 also. And next slide. A determinant remains unaltered under an operation of the form Ci plus alpha Cj plus beta Ck, where Jk are not equal to I, or Ri plus alpha Rj plus beta Rk, where Jk is not equal to I. Unaltered means unchanged. So these are called operations. You will clearly understand by observing the example. The notation R1 gives 2R3 minus 3R2 means the elements of the first row are added twice the corresponding elements of the third row and subtracted thrice the corresponding elements of second row. The notation R1 gives 2R3 minus 3R2 means the elements of the first row are added twice the corresponding elements of third row and subtracted thrice the corresponding elements of second row. Factor property: if a determinant becomes 0 when we put x equals to alpha, then x minus alpha is a factor of delta. X minus a and x minus b are the factors of delta. Next, triangle property. If all elements of a determinant above or below the main diagonal consists of 0, then the determinant is equal to the product of diagonal elements. For example, here in the left side, diagonal below we have zeros. And here, in the right side, diagonal above we have zeros. So, determinant is equal to the product of diagonal A1, B2, C3. Next, summary. We have discussed about Laplace expansion and shortcut method for determinant of order 3, properties of determinants. So based on this, you can do the quiz also, and I will send the PPT on WhatsApp group so you can do. So these quiz questions are covered in the slides, and do the exercise problems. If you have any doubts, you can ask me. Thank you.